I would like to thank everyone for coming today for the presentation, for the Sentinel of the Sea presentation, and to speak how whales and dolphins are essential to the Global Biodiversity Framework. So I'm really happy to welcome to the participators who came Ed, Julika, and Aurore. So thank you everyone. And just to present Leo to the one who participate, I can welcome Ed, who will address the issues of marine mammals on a more global context and from the point of view of his organization. I would like to thank Julika for being here from BioConsul, from and BioConsul being a partner of BIOTOPE. I would like to thank you, and to thank overall from BIOTOPE, who were working on a conservation was project on the Atlantic humpback dolphin in Guinea. So thank you everyone, and I can share my screen for the presentations. So I will share the presentation of Aurore first, if it's good for you. It's you first? Okay, sorry. I had this order. I'm sorry. Okay, so I will share the presentation of Ed. Just 1 second. Can you see the presentation?
It's not full screen.
Yeah. Okay. I will put it full screen. And I just have to mute me. So let's speak, Ed.
It was full screen and now it's gone back to the PowerPoint view. Yeah. Okay, great. Buenos dias. Hola. My name is Ed Goodall from Whale and Dolphin Conservation based in the UK. Thank you very much to BIOTOPE for inviting me to speak at this side event here in Cali at COP16. Yeah, if we could move on to the next slide, please, Sophie. Thank you. Oh, I forgot this has animations. There we go. Great. So yeah, at WDC, our ethos is to create a safe and healthy ocean for all cetacean species to thrive in. They deserve to be here just as much as we do, but and we need to undo those injustices that we've served upon them over many centuries, as whales and dolphins contribute to protecting all of us through the valuable ecosystem services that they deliver. Next slide, please, Sophie. So whales, dolphins, and porpoises, collectively known as cetaceans, are integral to maintaining the health, resilience, and functionality of marine ecosystems. They contribute to ecosystem functioning through nutrient cycling and carbon cycling, which are both essential for wider biodiversity, ecosystem resilience, and by extension, climate regulation. But cetaceans face numerous threats, which prevents parties to CBD achieving the targets of the Global Biodiversity Framework. There's a lot of gaps in data collection, monitoring, meaningful policy change and enforcement, and all of that requires urgent action from governments, IGOs, NGOs, and industries to meet those targets. And we've created this new report, which we're launching here at COP16, which showcases the interlinkages between cetaceans and the targets of the framework, as well as presenting some examples of successful conservation efforts, but highlights areas for improvement and proposes a non-exhaustive set of policy recommendations to meet the targets for all parties involved. Next slide, please. So I'm not going to go over all of the threats to cetaceans given the time that we've got this morning, but I will highlight some of the main issues that they face that hinder wider population recovery. So bycatch is the unintentional capture of non-target species in fishing operations, and it's the leading killer of cetaceans worldwide. An estimated 300,000 whales, dolphins, and porpoises die annually as bycatch, and that's being caught in nets or entangled in fishing gear. In some regions, the numbers are really staggering. For instance, in the Gulf of California, the vaquita, which is the smallest cetacean in the world, is down to fewer than 10 individuals, which is really essentially due to entanglement in illegal gill nets for totoaba, which in itself is an endangered species, which is caught for its swim bladder, which is exported to China, where it's used in soups and traditional medicines, and as an investment, which is driving the extinction of that species. In the Baltic Sea, another very small cetacean, the Baltic harbor porpoise, faces similar threats from bycatch in similar gillnet fisheries with fewer than 500 individuals remaining. But even large whales like humpback whales and grey whales are not exempt and are often entangled in fishing gear, leading to lethal and sublethal implications. Also, climate change, human accelerated climate change is causing widespread issues, which is shifting prey species, meaning cetaceans have to travel further and expend more energy to feed. And species like the North Atlantic right whale off the east coast of North America are having fewer calves due to this, and they're themselves also on the brink of extinction due to direct human impacts, also from entanglements and ship strikes. But climate change is really exacerbating that and making it happen much faster. Climate change is also causing ocean dead zones, unusual mortality events, and increased competition between species. Next slide, please, Sophie. Commercial whale going in 2024, Japan, Norway, and Iceland are still directly killing whales for human consumption when there's no nutritional need, especially in these westernized countries. In fact, whale meat has been shown numerous times to contain dangerous levels of persistent organic pollutants and heavy metals. But this year, Japan commenced hunting fin whales from its new whaling mothership. There's been a lot of investment from the government in this practice. Fin whales are globally classified as vulnerable by the IUCN, and Japan have set themselves a quota, which even states within their own documentation that this might cause local depletion and local extinction just within a few years. MPAs as well, that's a really hot topic here in Cali with the implementation of the 30 by 30 target, but we know that there's a lot of MPAs that have been designated due to presence of rare cetacean species, but without proper management plans and enforcement measures, as with lots of other MPAs that have been designated for all sorts of reasons, they don't achieve their conservation goals. Next slide, please, Sophie. So the continued emptying of the oceans, fishing down food chains, and expanding into new areas is causing food security issues for whales and dolphins. The expansion into the Southern Ocean krill fishery to produce food supplements that are not needed from a human health perspective are leading to many whales of multiple species foregoing their annual migrations because they know that they will not have built up enough fat reserves to make the journey to mate and give birth, which is slowing their population recovery after decades of commercial whaling. Underwater anthropogenic noise as well from all angles, shipping, oil and gas exploration, military exercises, reduces the ability of cetaceans to communicate with each other and increases stress hormone levels, which again reduces feeding, reproductive success. They're not evolved to live in a noisy ocean, and that's just exacerbating all of these other threats as well. I know that this is quite a miserable topic, but it just shows you that there's so many threats that we need to address to recover populations. Next slide, please, Sophie. So this table is within the report. It's a little bit messy. I appreciate it. You probably can't see all the details on the screen here, but it attempts to show all of the interlinkages between the threats, some of which I've just talked about, that are impacting survival and population recovery, mapped across to the targets of the GBF. So as you can see, those links are extensive and a lot of action is required from many different stakeholders to meet those targets simply from a cetacean perspective, not looking at any other species or habitats. But policy benefiting cetaceans can be turbocharged by linking the need for change to these global biodiversity framework policy aims. Often in cetacean policy arenas, change is bogged down in regional agreements and national plans, and the lack of implementation of resources is not prioritized by governments. But by making this case through CBD and linking conservation threats to the GBF, we can advocate for more rapid action. because we do have all of the solutions to address all of these threats. They just require prioritization by governments, buy-in from industry, and the resources to scale them. Next slide, please, Sophie. So in the report, we list under each target and highlight areas for action and examples of good practice. So again, I can't go through all of these, but for example, on Target 1, action on bycatch, commercial whaling, underwater noise, and vessel strikes can help parties meet their Target 1 objective. For example, Canada is already very proactive on this, using marine spatial planning to prioritize biodiversity recovery in areas such as the Pacific Northwest integrated management area. So the initiative involves integrated management of marine species with input from indigenous groups, conservationists, industry stakeholders, balancing economic activities such as shipping and fishing with conservation priorities and the protection of critical ecosystems within that area, including those that are vital for cetacean populations. So on Target 2, actions that reverse ineffective MPAs and prioritize ecosystem function recovery through species recovery and reducing pollution would help parties achieve their Target 2 objectives. So for example, in South American Amazon and Orinoco river basins, the pink river dolphin, or BOTO as it's called locally, inhabits this extensive riverine habitat. And there's a strong negative relationship between measures of habitat degradation and river dolphin density estimates across these two basins. So therefore, pink river dolphins are good candidates as an ecological indicators or flagship species for monitoring the conservation status of this broader whole ecosystem. So the conservation interventions that prioritize river dolphin health would recover the species, but would have a wider ecosystem impact on the degraded parts of this critically important part of the Amazon. Next slide, please. So on Target 3, action on bycatch, measures that reduce climate change impacts, implementing effective marine protected areas, bringing in much more regulated tourism measures, reducing anthropogenic noise, will all help parties achieve meaningful 30 by 30. It's not just about drawing polygons around areas and saying that they're protected. They have to have proper management objectives that are enforceable, so that we actually are meeting that target in a meaningful way. One thing that all parties could do to help meet their 30 by 30 objectives for cetaceans or marine mammals specifically is to utilize the important marine mammal area data set, which is a project that WDC has been part of and is led through the IUCN Marine Mammal Protected Areas Task Force. And it's a global mapping initiative that's created a distinct peer-reviewed areas that are important for all of the different life history stages of all marine mammal species, not just cetaceans. And by using that data set and building it into national and high seas MPA targets, parties will be able to ensure that 30 by 30 is really working for marine mammals and that they're protected throughout their ranges. Target 4, meanwhile, is hindered by the active killing of cetaceans. As I mentioned already, Iceland and Japan continue to hunt fin whales, who are classified as threatened under IUCN criteria, and that intentional killing of fin whales and other species where there is an extinction risk or data deficiencies means that those countries will completely fail in achieving their Target 4 objectives as they're actively working against it. Now, like I said, I haven't got time to go through all of the targets. We list out 7 to 23 targets that are relevant to cetaceans, but I'm happy to distribute a copy of this report to anybody that's interested after the presentation. So one of the things that I mentioned at the start of my presentation was data gaps to inform conservation initiatives. So now I'm going to hand over to Aurora, who will present on her work, which is aiming to achieve just that.
Thank you very much for this presentation. So I'm just going to share my screen. All right. Can you see my screen? Yes. Okay, perfect. So good morning, everybody, or good afternoon, and thanks for this wonderful presentation. So I am Aurore Malapert. I'm Director of Studies of the International Department of BIOTOPE, an international consultancy in biodiversity conservation. And I am going to present you the conservation project of the AHD in Guinea, implemented jointly by BIOTOPE and the consortium of the conservation for the Atlantic humpback dolphin, CHD, supported by Mubadala and its asset GAC, and managed by the Mohammed bin Zayed Species Conservation Fund. And just to let you know, here I am currently in Guinea, and I'm with my Guinean colleagues, as this project was implemented as well with our colleagues from BIOTOPE Guinea. So just first, as an introduction, a quick presentation of this critically endangered species on the IUCN Red List. So the Atlantic humpback dolphin is one of the 4 species of humpback dolphins currently recognized across the globe. It is a species that is found in shallow waters on the Atlantic coast of Africa and ranging from Morocco to Angola. They are often found as well in estuaries and mangroves and river mouth. So it has been estimated that fewer than 3,000 individuals remain in a 7,000 kilometer range. Though there are very few scientific estimates of population abundance. As Ed said previously, there is a lack of data, and this is a very cryptic species. So it's, for example, more complicated to spot it than the bottlenose dolphin. So the key threats that these species face had presented many different threats, so I won't detail them, but for this species, it's mainly bycatch, accidental capture during fishing, habitat loss and degradation from coastal development projects such as harbors, and disturbance as well from increased navigation. So this project, which lasted 2 years between 2022 and 2024, was multifaceted and had 4 main transversal objectives. So the first one was to improve the knowledge of the species through boat surveys and interview surveys, so especially with fishermen, but as well other relevant stakeholders, as we see later in the presentation. Then involve the local communities through environmental education and the production of a children's book on the conservation of the species and more globally on the marine ecosystem. Then implement capacity building of local government partners, the National Center for Aquatic Sciences, Kusura in Guinea, and other stakeholders, like the inspector for fisheries, for example, and so on. And the 4th objective was to develop resources that can also be used throughout the range, not only in Guinea, but as well in the other countries along the range that I showed before, so between Morocco and Angola. So the key element of the project was first to gather data on the AHD distribution and population along the Guinean coast, and especially in the Rio Nines estuary and North Freestyle Island. So this is in the north of Guinea. Indeed, in this area, there were previous studies that published the presence of the species in the area and estimated the population of Atlantic humpback dolphin. So the methodology deployed involved vessel-based surveys, focal follows, and photo identification of individuals encountered. So through the picture of the dorsal fin. And we recorded as well depth and water parameters to be able to analyze the habitat parameters that would be favorable with the presence of dolphins, would be linked to the presence of dolphins. As we can see on the map, we designed transects. They were designed to cover a variety of habitats such as mangrove channels, offshore waters, and mangrove chunks. So here we see how the observation is happening. So with 2 observers in front of the boat, and there were 2 observers as well at the back, and this is our colleague recording water parameters. So just in terms of effort, in order to have a better understanding on the population areas of Crystal Island. We implemented 3 sessions in this area, so in the north. And in order to document as well the presence along the coast of Guinea, we sampled 2 other areas, one in Bofa and one around Conakry, the capital, and Île-de-Los. So in terms of results, over the 3 surveys that we had in Crystal Island and Rio Inlet estuary, we had 9 sightings of Atlantic humpback dolphin, as you can see on the left-hand side map, and 8 sightings of common bottlenose dolphin. So unfortunately, we only had cetacean observations in this area and not in Bofa area and Conakry area. However, we cannot conclude from this result that this species is not present in Bofa and Conakry. It's just that we had bad weather conditions, and so we will need to implement more surveys in these 2 other areas to be able to double check that the species is really not present there. Moreover, we have the interview surveys that I'm going to present after that indicated that dolphins may be present in the southern part of Guinea, but due to logistical constraints, we couldn't implement it with the board surveys. So through photo identification, we managed to estimate the minimum population at 65 individuals and a maximum of a few hundred individuals Atlantic humpback dolphins in this northern area of Guinea. So through mark recapture modeling, we managed to estimate the population size. So it's a method that is principally based on recapture probabilities. Basically, the bigger the population is, the less chances we have to recapture the same individuals. As we can see on the pictures, there were some individuals that were taken picture of for the 3 surveys that were in different years and different periods. So this allows us to, through modeling, estimate population. We studied as well the compilation of a catalog of the Atlantic humpback dolphin individuals in Guinea with moderately or highly distinctive markings, which was provided to our partner, the National Center for Halieutic Sciences. So yes, our main Guinean institutional partner. And they will be able to update this catalog following the next surveys that will be implemented. So the other pillar of this knowledge improvement about the species in Guinea were the socio-ecological studies related to the species, and especially interview surveys realized in several fishermen communities along the coast. The goal of these surveys, additionally to increase awareness of local communities about the species and the risk of bycatch, stranding, were to try to document as well the distribution and relative abundance of Atlantic humpback dolphin by sampling the experiences of the fishermen along the coast. And then another objective was as well to assess the threats posed by the Guinean fishing sector and other coastal human activities to cetaceans and the humpback dolphin in particular. So just to give you an overview of the effort, here is the map of the Guinean coast. So our team implemented the interview survey in 3 areas, in Forêt-Carrière, Grand Conakry, and Cap-Saint and Tristão. So you see that the boat surveys couldn't go to Forêt-Carrière. That's our, because it requires a lot of logistic and specific boats to go and see, but our social team could go there and get a very interesting, insightful data on the link between dolphins and the fishermen. So they implemented 4 campaigns, including 1 pilot study in Conakry. They surveyed 22 artisanal fishing ports in these 3 main areas, and they could deploy more than 600 globally, 600 surveys. So this was very, very important. This is a very big database that they managed to create, and that brings a lot of very interesting information that we need to be dig even more than what we did what we could do in the framework of this project. So they use the specific application. So they use Kobo Toolbox to be able to collect data from the interview surveys. And this generated, as I was saying, a very big database with many informations. So here I'm just going to give you a selection on these informations and focused on the threats on the species. So here appear the results of the questions related to bycatch. So the question was, have you ever heard about the bycatch incident with dolphins? Globally, around 10% of the fishermen replied yes in the different areas surveyed. And when being asked about which species was mostly involved in the bycatch, the majority was for the bottlenose dolphin. This was consistent with our observation during the boat surveys, when we could witness fishermen dolphins interactions. This was mostly with the bottlenose dolphin. We could see this information. So in this interview, we learned as well that the small scale artisanal fishers that operate the Atlantic compact dolphin habitat are predominantly using gill nets. So this is a gear known to have the highest risk of dolphin bycatch. We wanted as well to document stranding episodes, as it is another important threat at the scale of the AHD distribution range. So in the graph on the left, we can see the differences between areas, and we can see that roughly 45% of fishermen questioned for the 3 areas have already seen and not just heard of a stranded dolphin, which is quite concerning result. And especially in foreign areas, so in the south of Guinea, we see that most of the fishermen, the majority of fishermen, already saw a stranded dolphin. And this was actually validated and comforted with the last episodes that we had for stranding, because now we launched a network for stranding, and we could see that most of the stranding events are located in these areas. So, launched in September, this network is based on the WhatsApp community with 2 different groups, a global group gathering field informers such as fishermen, focal points, communities, port ships, local coastal offices, biodiversity reference from voluntary mining companies, and a small group scientific committee with a selection of international and national experts in science, but as well in manatees and marine turtles to encompass these marine species at threat as well. So it works as follows: the informers send information about the stranding with the GPS location, the coordinates, pictures, date, and possible hour observation. Then these elements are analyzed and debated in the scientific committee group, where an idea is collegially identified, and the responsible of the network, the CNSHB, is posting this validated idea on the global group in order to improve knowledge of the whole network on species identification and give them feedback on their observation. Obviously, there will be a database. These data will be compiled in a database at the national level. Another important dimension of this project was capacity building of relevant stakeholders. And this was really at the heart of the project, because we really want to form and train a team here that can continue by themselves to surveys in the long term. So we train young local scientists at the project focal points at the National Center for Biotic Sciences. So we can see that we train them for different aspects that comes from data collection to with the GPS use for transect navigation, observation techniques, how to take good photo for the photo ID, how to download the data from the GPS, use of water sampling, and so on. We supplemented as well already well-developed existing resources on the AHD website through the development of different material in the projects, such as a guide to perform interview surveys and a children's book with lessons about marine environment that we developed from conception to production. Our team in Guinea started with going through the harbors in Conakry to look for a storyteller and that could tell us a story about dolphins that we could then make a book out of it with award-grade illustrator. And we even managed to be able to sell this book in order that sales in Europe and the US can fund conservation initiatives coordinated by the CCHD. So here are just key figures of the project to summarize my presentation, but I'm not going to present in detail, but at least you have it in the PowerPoint if you are interested in the project and want to retrieve these data. Now, just to conclude, as this project finished last September, we want to build on the success of the project and on the stakeholder engagement momentum that this project created at the national and international level to ensure this project has a continuation in the short, middle, and long term. So it would be important first to continue the board-based surveys and photo identification. In the area we already extensively surveyed, but as well in other areas around coast in Guinea. Then developed other monitoring techniques, such as acoustic monitoring, for example, in collaboration with other NGOs or institutions that have set them up in other countries. Continue and develop the capacity building of the relevant stakeholders of the local and national scale as well. As, for example, fishermen, focal points that can send information when they are at sea, when they observe the species. Continue and expand the outreach, education, and stakeholder engagement. We can see here that we developed some resources like a memory game that we tested in during an environmental education session at the school in Conakry. That was very interesting, and yes, the kids really liked it and were very interested in dolphins ecology and the way they can help to conserve the species. They were all kids of fishermen. Another orientation will be to identify fishing communities willing to work with research teams to develop and test reduction methods, which could include time area closures, alternative to gill nets to decrease the bycatch episodes. And all these actions, in order to organize all of them, we will need to realize a national conservation action plan of the Atlantic humpback dolphin in Guinea based on the existing regional single species action plan already developed. Indeed, this national action plan will be the overarching document that will lead to and be able to advise the different stakeholders at the scale of Guinea to pursue the conservation objectives for this species in Guinea. So now we are trying to approach potential international donors and developers to find funds to continue this exciting and meaningful project. And we hope we can continue these collaborations that we built here in Guinea and with the international community of cetaceans researchers. Thank you for your attention.
Thank you very much. And then I can let you, Julika, put your presentation.
Yes, thank you so much.
Thank you.
Can you see my screen?
Yes.
Perfect. Thank you, Aurora. Thank you, BIOTOPE, for also inviting me to speak here about Spacewell, and thank you, Aurora, for just telling so much about a really amazing conservation project. And I think we need more of these conservation projects, but sometimes we do not even know where the whales are, so we do not know where to do conservation projects. And this is where my presentation comes in. So I would like to present Spacewell, and namely using satellite imagery to survey whales from space and remote areas, and thus to enhance conservation efforts. If you remember COP15 in Montreal 2 years ago, we had the 30 by 30 target, which means we aim to protect 30% of both land and sea by 2030. And this target is already set, so now we only need to discuss how to actually implement this target. And for implementing, it's still really a long way to go and for achieving it, because more than 80% of our ocean is unexplored. So in particular, in the high seas, we really have a small global survey effort. And this is mainly due to our traditional survey methods. So we used to do ship-based transect surveys or digital aerial surveys or passive acoustic monitoring. But most of these methodologies are really limited to shore. However, new technologies like satellite imagery can really change this. So with satellites, you can go into any area of the world, take a snapshot in time, and then count your whales in there. And this is namely what Spacewell is making use of. So we are detecting whales from space using satellites, and this is what we offer as a service. In this way, we determine their number and distribution in large areas where it's too challenging for traditional survey methods, and then we can use whales as indicators for a high biodiversity and use these data for baseline studies, population assessments, and conservation efforts, helping evidence-based decision-making. We mainly use the WorldView 3 satellite by Maxa, which has a resolution of 31 centimeters per pixel. However, we also use the WorldView 2 satellite by Maxa and the Pleiades Neo satellite by Airbus. And now you might wonder, how does a whale look like in 31 centimeters? So if you have a blue whale, for example, 30 meters in length, it would appear in 100 pixels. And I'm going to show you a few examples now. Always on the right-hand side, the satellite imagery. And for comparison, just like what you see in the satellite imagery, also a drone footage on the left-hand side. So here, actually, you can see a perfect shot of a blue whale. Here, the tip of the blue whale, like the head, then the flippers over here and the fluke. But if you've been on a boat before, or if you've seen whales before, you know, like usually you only see parts of the whale which are on the water surface. So for example, only the flippers and the back, or only for the fluke. And this is also what we usually only see in satellite imagery. So here, for example, again, a blue whale where the back is above the water surface, like this part over here, and the head is already beneath the water surface. And also the fluke is still beneath the water surface. So this is what we usually see in satellite imagery. And then you have species like humpback whales, which are really playful and splashy and creating waves. And we can also see them in satellite imagery. So here, the humpback whale is laying over here, like this part over here, and then raising its flipper out of the water, like this part over here. Or when humpback whales go down, they usually raise their fluke out of the water. So this is also what you can see here, actually, the shape of the fluke of a humpback whale. But yeah, now you must imagine if you search for these tiny pixels in thousands of square kilometers, it's really time consuming and also exhausting. So this is why we said we need artificial intelligence. So we trained an algorithm which was based on aerial imagery, and then we downsampled this footage to the resolution of satellite imagery. Later on, we also used drone footage from various species and scientists all over the world. And then now, of course, we have already conducted several successful projects and used the satellite imagery from previous projects for further enhancing our algorithm. However, for an algorithm, sometimes it's also really difficult to say if it is a whale or not. Imagine a paddle boat from above. So you have the paddles, which might look like flippers from a humpback whale. So this is why an algorithm sometimes struggles to say if it is a whale or not. And this is why we are combining state-of-the-art artificial intelligence and then a manual expert quality assurance. So in the first step, we run our algorithm using artificial intelligence. And in the second step, every object which was identified by the algorithm is verified by a large expert review team. So they are verifying that the object is actually a whale and not a rock or a wave or foam or a vessel or anything else. And in this way, we already did several successful studies all over the world. And I would like to show you one example we did in New Zealand. And namely, we did this example in Port Ross over here. So if you know the shape of New Zealand, Auckland Island is in the south, and then Auckland Island is big, and we had a look on Port Ross. And Port Ross comes with some history as it was one of the former whaling grounds. So numbers of southern right whales dramatically declined in the first half of the 19th century. Now numbers start to increase again, but obviously you have upcoming threats, which were already mentioned by Ed. So it's really important to continue monitoring. And this is why we did a study over there. And we used satellite imagery. I guess you can already see one southern right whale over here, but I would like to focus on this one. So here, the white part, this actually is the head of the whale. Then here you can see the flipper and the back. But if you have a closer look, there's something white over here as well. And this is actually a calf beneath the mother. So we were really able to see mother-calf pairs within this region. So what we do is we have different categories. We have adults and calves, and then we have also different likelihood categories. So sometimes even expert reviewers are not quite sure if it is a whale or not. So we have definite whales, we have likely whales, and we have possible whales. And for further analysis, we always only take into account the definite and likely whales for making sure we only count really whales where we are sure that these are whales. But then we were wondering, like, how reliable are our data? So what we did is we compared our data. We contacted local researchers, which were doing a study within our study area. And we were really lucky because they did a boat-based survey actually 12 hours before we did our satellite survey. And when we compared numbers, actually both methodologies observed 41 southern right whales in total. So we showed that the data were comparable to the results of traditional survey methods and that Spacewell can either complement data in explored regions or provide baseline data in unexplored regions. And now Spacewell teamed up with whale and dolphin conservation, so Ed and his team, because they can use our data for creating important marine mammal areas, creating marine protected areas, and supporting redirecting fishing and shipping traffic in critical areas. This is why we are currently doing a proof of concept study in the Indian Ocean over a study area of 4,000 square kilometers, where we think that there are various cetacean species, but actually we really have a lack of data. So this is also the reason why these areas are so far only designated as ecologically or biologically significant marine areas, because we are just lacking data. We are then now doing a study there, and we use whales as indicators for high biodiversity, and this is why our aim is then designating these areas as important marine mammal areas and marine protected areas. But obviously, this also depends on the results, how many whales we will count in these areas. And now going back to the beginning, so this really shows how we can fill the knowledge gaps on large areas to really achieve the 30 by 30 target we set 2 years ago. So our hardware and software are in place and we are ready to map further whales from space. Thank you.
Thank you very much, Julika. So we can start a moment of questions and answers, and I can unmute the participants. So if they want to ask something, they just have to activate microphone. And so feel free to ask anything. If there is no question, I think I can thank everyone for participating and for the ones who presented this work. That was really interesting. And thank you very much.
Yeah, and just I see that Madame Diallo joined us online. So she's the Deputy Director of the National Center of Halieutic Sciences in Guinea. So I would like to thank her for her presence here, and this shows how much is important that the local stakeholders and national stakeholders are involved, and this really shows how much they care for this species of the Atlantic humpback whale climate. We hope that we can continue to collaborate together. And as we are in collaboration as well, I have a question maybe to Julika. Because so we would like to develop other more tech ways to be able to monitor the Atlantic humpback dolphin. Do you think that this would be possible to develop this, as obviously the dolphins are smaller than whales? Do you think that one day maybe we can manage to do that with the improvements already that you saw in the last years? How much you can really develop methods, and what is your thoughts about it, just as perspective?
Yes, so I'm sure that we will, at one day, we will be able to see dolphins in satellite imagery. So for now, we say we can detect whales which have a body size of larger than 9 meters. And basically, the idea is why we say 9 meters, because usually if you have a whale, like a pilot whale, for example, which has about the size, you will always only see parts of the whale which are on the water surface. So you will never, or usually not, see 9 meters of pilot whale on the water surface, but only like 2 or 3 meters on the water surface. And the same would apply with a dolphin. Even though the dolphin has a size of, let's say, 2 or 3 meters, you won't see the 2 or 3 meters of dolphin on the water surface, but let's say then only about 50 centimeters. And 50 centimeters now would appear in 1 to 2 pixels in satellite imagery. So this is why we are currently not able to see dolphins in satellite imagery with a resolution of 30 centimeters. However, it was already announced that 10 centimeters of resolution will be commercially available like this year, but I guess it will take a few more years until it will really be commercially available. And then we will also be able to see whales or smaller whales and dolphins in satellite imagery, which we can't see at the moment in satellite imagery. And also maybe one further point, even though we say, for example, 9 meters and above, we already saw some dolphin, like schools of dolphin in satellite imagery. But in this case, we're not able to identify the species anymore, for example. So this is why we usually say 9 meters and above. So yeah, thank you.
Thank you. So if there are no other questions, maybe thank you all for coming and attending this event. I was very honored to be able to present with Julika and Ed. Yeah, thank you very much, and enjoy the end of the talk for the ones who are there, and have a nice afternoon for the others. Thank you. Thank you. All right.
Thank you very much for everyone.
Thank you, everyone.
Thank you so much.
It's a pleasure to be here.
Yeah.
Thanks. Bye.
Thank you so much for inviting. Bye.
Bye.